Welcome for today's session. This is Mwalimu Theophil Academy. If you are a new one, I take this chance to welcome you in our channel. If you have not subscribed, make sure that you subscribe so as to get updates whenever we upload any video in our channel. Yes, now welcome for today's session. Today I am going to state the principle of moment for you to learn together with me, and after testing the principle of moment, I'm going to clarify it so as to know it in detail. Now you are welcome. The principle of moment states that when a body is in equilibrium, the sum of clockwise moments about a point is equal to the sum of anti-clockwise moments about the same point. That is to say, now just assume we have this ruler. This ruler to be in equilibrium will mean that, for example, just let me balance on my finger. Now you may see this ruler here. I can say that it is in equilibrium, as you can see as it is. But when maybe I position it in another part, you see it goes in one side. It falls in one side. Or when maybe I touch here, after letting it falls in another side. So when it is in this way, we say that it is not in equilibrium. But when I balanced on exact part, maybe here you may see it reaches a time where it becomes in equilibrium. So here this is in equilibrium. Now if it is under the action of forces, maybe just assume I put a certain weight here and another weight here, the sum of clockwise moment becomes equal to the sum of anti-clockwise moment, provided that this ruler is in balance. When it is in balance, it balances horizontally, as you may see. Now let us see what I was talking about. Just take your ruler like this one. Take your ruler like this one. This is our ruler. This is our ruler. Now this is the balancing point for it when it is in equilibrium. Take this is a balancing point. This is a pivot. Now if this is a pivot, just say we have weight 1 here. We have weight 1 here is, let us say, W1. Also we have weight 2 here. Weight 2 at this part. We have weight 2 at this part, W2, just to say W2. Now, the distance, the perpendicular distance from W1 to the turning point, just to say it to be D1. It means that the distance from where W1 acts to the turning point, which is the fulcrum here, as you can see, this is D1. And let's say the distance from W2 to the turning point, just to say it is D2. It is D2. Now, from this diagram, from this setup, as you may see, we have two weights, W1, W2, and you have two distances, D2 and D1. Now, when we speak about clockwise moment, is obtained when we take the force which moves in clockwise direction times its perpendicular distance to the turning point. How do we recognize the clockwise direction? The clockwise direction is the direction which is the same as that of the arrow of the clock, as it moves this way. So you start from where the weight acts to the turning point. So when you move this way as an arrow of a clock, you get a clockwise direction, as you can see. So in our diagram where clockwise direction will be due to weight 2. As weight 2, it will be moving this way towards the turning point. So this way is the same as that of an arrow of the clock, as you may see. Now this, we say it is a clockwise direction. is it moves the same way as that of an arrow of the clock. As you can see, it moves this way towards the turning point. Now let us see the anti-clockwise direction. Anti-clockwise direction is the direction which is opposite to that of an arrow of the clock. So anti-clockwise direction, instead of going this way, it moves this way. So as you see, W1 will be moving in anti-clockwise direction, as every force must be moving towards the turning point. So when this is rotated towards the turning point, it means it moves this way. It moves this way. So this is going to make the anti-clockwise direction. Anti-clockwise direction. Anti-clockwise direction, as it moves in opposite direction to the clockwise direction, as you may see. Now, after there, let us find the clockwise moment. The clockwise moment about the turning point. The sum of clockwise moment, let us use the term sum. The sum of clockwise moment will be equal to, we have to look all forces which are moving in clockwise direction. We have only a single force, this one. It moves in a clockwise direction about a turning point. So we have W2. As you have to remember, clockwise moment, any moment is the force times perpendicular distance. So clockwise moment will be W2, which moves in clockwise direction, times the perpendicular distance. Its perpendicular distance is the distance from where the particular force acts to the turning point. So it will be W2 times D2, as you may see. From this, where the force W2 acts, the distance from here up to the turning point we have rated to be D2. So it will be the sum of clockwise moment will be equal to W2 times D2. Now let us see the sum of anticlockwise moment. The sum of anticlockwise moment will be equal to the particular force which moves in anticlockwise direction times its perpendicular distance from where it acts to the turning point. So it will be it will be W1 times D1. W1 times D1. Now, according to the principle of moment, according to the principle of moment, we have said that the sum of clockwise moments is equal to the sum of anticlockwise moments. So the sum of clockwise moment is equal to the sum of anticlockwise moments about a turning point. This is according to the principle of moment. Here, the sum of clockwise moment we have W2 times D2. Now, the sum of anticlockwise moment we have W1 times D1. So this is according to the principle of moment, that W2 times D2 is equal to W1 times D1. This is to say, if maybe if any of the four parameters, if it misses, maybe you are not given D1 or D2 or W2 or W1, you will be in the position of calculating it through using the principle of moment. For example, just assume if maybe we have this setup, we have this, maybe it is a ruler, and at this ruler it is balanced at this point, and maybe weight one, maybe we have 20 Newton, weight. Maybe its perpendicular distance, just to say it is 30 centimeter. Now, let's say we have another weight here. Which is hung at this point, at this mark. Maybe just say its weight is, maybe we have 50 Newton, and you are asked to calculate the distance, the perpendicular distance D. The perpendicular distance D, maybe or say, let us say, X, the perpendicular distance X. Now, what will be the value of x? When you apply the principle of moment, you will be able to find the value of x without any problem. Here, what you will do will be, you will take, according to the principle of moment, sum of clockwise moment here will be equal to the sum of clockwise moment. Clockwise will be made by this force, while anticlockwise by this one. So this is clockwise direction, this is anticlockwise direction. So the sum of clockwise moment will be equal to, maybe let us change this. Let us change this and make it 60 Newton. 60 Newton. 60 Newton. So the sum of clockwise moment will be 60 Newton times x. Times x. It means the weight times its perpendicular distance, which is x. Sum of anticlockwise moment will be equal to, sum of anticlockwise moment here will be equal to the force which moves in anticlockwise direction, which is 20 Newton, as you are given, this one 20 Newton, times its respective perpendicular distance, which will be the distance from where it acts to the turning point, which is 30 centimeter. 30 centimeter. Now, you will apply the principle of moment. When you apply the principle of moment, it comes this way. After applying the principle of moment, what you get here, now, what you are going to get will be this. According to the principle of moment, according to the principle of moment, sum of clockwise moments is equal to the sum of anticlockwise moments. Now, sum of clockwise moments, you will have 60 Newton times x. So it will be equal to sum of anticlockwise moment, which is 20 Newton times 30 centimeter. Times the 30 centimeter. Now, to get x, we are going to divide by 60 Newton, both sides, by 60 Newton, both sides. Now you are going to have x will be equal to 20 times 30, you are going to get 600 Newton centimeter, and this is 60 Newton. So 600 over 60, you are going to get 10 centimeter, as Newton will cancel out. So the distance x will be equal to 10 centimeter. Now this will be the answer. So I hope you have got well the concept of principle of moment and the way you can apply it in dealing with their problems which you may counter with. Now, let me take this chance to thank you for attending today's session. I welcome in the next sessions. Have a nice moment.